Hi friends, let's introduce logarithms. Now the first conversation I'd like to have around logarithms is why we need them, which is a really good question and a conversation we should have. So let's talk about why we need logarithms. Now we know in math, everything has an opposite, and those opposites allow us to solve for things. So if I have an equation and I'm adding something, I can subtract it to get rid of it. Or if I'm multiplying, I can divide to get rid of it. Or even if I'm square rooting, I can square to get rid of it. Everything has an opposite so that you can get rid of it and solve. So let's think of that with this equation. 3 to the x equals 7. Now, first thing you might try is our one-to-one property. But I can't change 7 to base 3. That doesn't work. So at this point, we're kind of stuck. There is no way to get rid of this 3 and get the x by itself. That is where logarithms come in. Logarithms are the opposite of exponentials, which means they undo exponentials. So if I took the logarithm, base 3, of both sides of this, those would cancel, and now I can solve this problem. That is the whole point of why we need logarithms, is so that they're the opposite of exponentials and they allow us to undo exponentials and solve for x. So let's get into logarithms then. You've probably seen things written like this. Log base 2 of 8 is how we say it. And you'll notice that it has a lot of the same vocab that exponentials do, namely the base. And that will become important in a little bit. Logarithms, however, their base is the smaller number versus an exponent, the base is the bigger number. So, now that we know that, let's come to right here. Let's try our very first logarithm problem. Now, if I just gave you this problem, you'd probably look at me and go, Mrs. Johnson, you're crazy. I can't do that in my head. And you're probably right. So, we have a trick to be able to solve this. Right now, this problem is in log form. And while it's in log form, we can't solve this. We don't know what this thing equals. Mostly because you're not really familiar with logarithms yet. You need more practice with them. So what we're going to do is change it to a form you are more familiar in, which is the exponential form. So if I change this logarithm from logarithmic form to exponential form, I'm going to do 2 steps. Step 1, the base stays the same. And here's what I mean by that. In exponential form, it's going to look something like that. Something to the something equals something. Well, the base of the logarithm becomes the base of the exponent. So now let's look at step 2. We know that logarithms and exponentials are opposites. Another word for opposite is inverse. They are inverses of each other. And we learned back in chapter 1 that to have an inverse, the x's and the y's flip. Well, I can do the same thing here. To change from log form to exponential form, the input and the output flip places. The x's and y's flip. So before this 81 was my input, it's inside the logarithm, so that 81 is going to move out here to become my output. And before this x was my output outside the logarithm, now it's going to become my input inside the exponential. And you'll notice that having it written like this is a lot easier to visualize what x should be than when it's written like this. Mostly because you're not very familiar with logarithms yet. So if I look at it this way, it's very easy to see that, well, 3 to the 4th equals 81. So x has to equal 4. So that means over here, for this logarithm, log base 3 of 81 is 4. And hopefully you'll start getting used to thinking of logarithms as 3 to what power gives me this. That's kind of what you want to think of. 3 to what power gives me 81? And that's the answer to the logarithm. So let me give you another simple example. one like this. So we think 10 to what power gives me 100? Well, I know 10 squared gives me 100. And that is how we start to find logarithms in our head. So keeping that in mind, let's look at B. We want 5 to what power gives me 1/25. This one might be a little harder to see. So let's actually write this out in exponential form to visualize what's going on here. So base stays the same, input and output flip, 5 to what power equals 1/25. And it might be a little harder to see this. So let's start by saying that I know that 25 is 5 squared. And that seems to be getting us a little closer. And I know that I can bring this exponent up for my exponential rules, and when I bring it up, it just changes the sign on the exponent. So now, using my one-to-one property, it's really easy to see that x should be -2. So 5 to the -2 equals 1/25. That's how we can start to think of logarithms. Now, if we think of that here with C, where I think 8 to what power gives me 4. That's a little harder to think about. Let's write it out. 8 to what power gives me 4. I can't really change 4 to base 8. So I can't use my one-to-one property, which means that this is actually a calculator question. And if you have a TI-36X Pro, or most of the Casios, scientific calculators will have this button, the TI-36 and the Casios will have a log button that you can push, and it will give you something like this. And then you can just fill that in with an 8 and a 4 and hit enter, and it will give you the answer, which is pretty nice, especially in 1050 where the whole test is calculator allowed. That means I can just type this into my calculator and move on with my life. So you actually could have typed all of these into your calculator, which is kind of nice. Okay, let's move on to our next one, and then we'll end this video. These ones should be pretty fast. I just want to convert from logarithmic form to exponential form. This is something we've already practiced. The base stays the same, and then the input and output flip. So the input is going to turn into an output, and the output is going to turn into an input. And there we go. You'll notice that's our fractional exponent rule. 6 to the 1/2 equals square root of 6. So let's try B. This time I'm changing from exponential to log form. But thankfully, it's the same 2 steps. Step 1, the base stays the same. Step 2, the input and the output flip. So that -3 becomes the output. This 1/1000th becomes the input. So log base 10 of 1/1000 equals -3. And that should be everything you need to know about switching a logarithm and an exponential back and forth. Let's do 2 more quick practice problems where we use this to actually solve a little bit better. If you notice in this logarithm problem, I'm kind of stuck where I am. I can't solve for x anymore. Once you get to a place where you're stuck, I always try to switch the form and see if that makes it look easier. So if I switch the form, I get 3 to the 4th equals x. That's what it would be in exponential form. And hey, look at that. This is way easier to solve now. 3 to the 4th is 81, and I'm done. Come over here to B. I'm kind of stuck, can't solve solve for what x is, so change the form. Base stays the same. Input and output flip places. And hey, look at that. Now this is way easier to solve because 2 cubed is 8, and then I can solve for x to be 9. So that is a brief introduction to logarithms and how to switch from log form to exponential form and vice versa. In the last video of today's lesson, we're going to graph logarithms and talk about that. Then each lesson in this chapter, we'll just go into exponentials and logarithms a little more in depth with each lesson.